Hey everybody and welcome. In today's video we're going to be talking about challenging examples of factoring. So in yesterday's class and the last lesson we did, we were taking a look specifically at when we have examples of things that fit nicely into the box and we can solve evenly. We're going to be looking at today when it's a little bit less clear and there's slightly more complicated steps to follow, basically when our numbers get bigger, and that's what we're trying to take a look towards, is when numbers get bigger. So factoring is the word that we got, and let's make sure we jump in. I'm in the wrong app for writing notes here. So factoring is our word, and this is a number or expression that divides evenly into another number or expression. So when we are looking at things, for example, like 36, when we're listing the factors of it, we would see 6 and 6 are both factors. They divide evenly into 36. But if we add something like 7 times 5.14, repeating, we're going to see that because we have a decimal here, it's not evenly going into 36. So that would not be a factor. So we're just looking for things that can cleanly divide into each other. Now, yesterday, what we were doing is we were looking at boxes and looking for terms that basically using what we have, trying to fill in the rest of what's there. So that's kind of the goal of what we're looking towards today, is more on this side of things, trying to fill in the rest of boxes based off of what we have. So the problems become challenging, and we can't use the things that we used in our last lesson when our first term next to x squared is no longer a 1. So there is a number there instead. So when this happens, we have a new method that we have to bring to the table to basically use for solving. And if we use this method, we'll be able to follow these steps, and it should work for us every time. So this is the X method of factoring. So the first thing that we do is we take our first and our last terms, and we multiply them. So we'll do 6 times 6 here to get us 36. The next thing that we'll do is we'll take, this time, our middle term, 37, and we're going to take that middle term and we're going to write it directly down on the bottom. And so once we're here, we need to have something that adds up to 37 and multiplies to get 36. So we're thinking about any two numbers that multiply to get 36 and also add up to get 37. So for example, if we did 6 times 6, that's 36, but 6 plus 6 does not equal 37. So that's what we're kind of looking through. So a good way to do this is, if you're not sure your factors, you can just list all of them out here. And then we can see, we know that all these multiply to get us 36. So we can see all of these actually add to get 37. So yeah, that one's 12, 13, 15, 20, and then there we go, 31 and 6 is 37. So it looks like if we use 36x and 1x, 36 times 1 is 36, and then we also know that 36 plus 1 is 37. So the usefulness of this is these two side numbers here tell us how we can fill in our box. So we know that our first term is still our first term. We know that our last term is still our last term. And now, in yellow, that tells us what to fill in. So we can put 1x here and 36x here. So using this x method right here, it helps us fill in all 4 squares of the box, because otherwise we'd have no idea what's in yellow highlighter. So our job from here is to figure out what the outsides are. And this is where we have to do a little bit of guessing and checking, but just following our process until it works. So if we have x squared, there's at least 2 x's here. And we have to get something that multiplies to get 1x in the top right corner. So it looks like x times 1 is the only option there, because otherwise it'd be impossible to fill in that box. And then now we know that we have 1 here, so the only thing we can multiply 1 by to get 6 is just 6. So we have to have 6 in the bottom left corner as a result. And then we also need to have some terms here that can get us 6 and 36. So put a 6 here, 6x times 6 does get us 36, and then 6x times just x does get us 6x squared. So basically the key to this puzzle was having these two boxes filled in, and that let us work backwards to get the edges of the box that we do have. So our final answer for this is we have 6x plus 1, and then x plus 6 is our second one. So let's take a moment on our second one and see if you can follow those same steps to fill in our x here with what we did before. So our first top part here, 2 times -3 is -6. And then on the bottom, a reminder that that's just where our middle term goes, which in this case is -5. So we need things that multiply to get 6 and then add together to get 5. So if we try for -6, we should just list out all of our factors first. We have 1 and 6. We also have 2 and 3. And it seems like, yep, those should be the only ones that we have here. So let's see what we get when we put 1 and 6 and add those together. Or actually, negative sign here. So we should subtract these. So we get -5 for the top one and -1 for the bottom one. So 5 is the number that we wanted. So if we use -6 and +1, -6 times +1 gets us the -6 on top. -6 plus +1 gets us the -5 on the bottom. So what that allows us to do is, just like before, that -6 and that +1 fill in the sides of our box. So we know that we'll have 1x here and -6x here. And our first and our last are the same as always, so 2x squared minus 3. So that'll always be given. We don't even have to think about that. We can always fill in that top left and that bottom right. So using this helps us to be able to basically go backwards and fill in the sides of our box. So as always, x and x. And we know the only thing x times 1 gets us 1x. We know that we have to lock in a 1 at that top right corner, which means we have to lock in a -3 at the bottom corner, because 1 times -3 is the only thing that can get us our bottom right box. So then now we have to make this one a 2x, because otherwise we wouldn't be able to get our 2 here or our -6 here. So by using that method, we have 2x plus 1 and x plus 3. Sorry, x minus 3. So that's the key there, is really just trying to fill in that box using that x method and then really just working backwards. So on to our next page here, we're going to take a look at some of the special cases that we have for going through and factoring. So if we ever have the difference of squares, so x squared and 49 is also a square because 7 times 7 is 49. Basically what this is just saying is we're missing our middle term. We don't have 0x there. So we can just follow the exact same method that we did yesterday. So we can go through, work through this question. We have our first and our last. We have -49, and we're looking for 0 actually now. So our middle term should be 0 when we put everything together. So we still have 49 and 1, and 7 are the only other ones. 7 times 7 is 49, and that's a negative sign. So we get 48 there, and we get 0 there. So that's actually our match, is 7 and -7. So we fill in the sides of our box. That's what we're looking for, and that's how we find our difference of squares, is we just have that middle term as 0, and we follow the same steps that we've been following for quite some time. So the same thing is true for all the rest of these questions, is we just want to use the same methods that we know, and we just want to put in a 0 as the middle term there. So same thing here, 0 is our middle term. Same thing here, 0 is our middle term. So as long as we're doing that, we're in good shape to be able to go through and finish solving. Now, the next thing that we have to do does have a formula for us, which is nice, is the sum and difference of cubes. So we'll start off with the sum of cubes. So the formula for the sum of cubes is as follows. It's a plus b times a squared minus ab plus b squared. And this is equal to 2 cubes added to each other. So a and b cubed is the sum of cubes. So in this situation, what we need to do with these questions when we see to the third power is take our first term and set that equal to a cubed. So x cubed in this case is a cubed. And then the second thing that we do is we take our second term and we set that equal to b cubed. And what this allows us to do is to solve for a and b. So just a is equal to just x. And in this case, just b, if we take the cube root of 125 in our calculator, or if we just know that 5 times 5 times 5 is 125, we see that our term for b is just 5. So we can take this now and plug it directly into our formula from below. So for the sum of cubes, we would have a plus b, so x plus 5, and then a squared, x squared, minus a times b, so 5 times x, plus b squared, so 5 times 5 to get us 25. And that would be how we would factor out our sum of cubes. Now for the difference of cubes, we have a slightly different formula, but we follow the same concept. So now we do a minus b out front, and then on the inside we have a squared plus ab plus b squared this time. So two minor sign changes to this, and that gets